earlier in this day, scientists have made a momentous announcement saying that they have probably discovered something what is close to call the God particle. So Leslie, what are your first thoughts on this?
Yeah, it's a very exciting development because if you recall, earlier in the year, CERN had made a similar kind of announcement.
That's right.
And that turned out to be some kind of an interference. So there was a massive disappointment among the scientists. Everybody was looking forward to this announcement. In fact, when they said it's 4th of July, I remember the amount of tweets that came up with it.
Yeah.
And I think basically what the ATLAS and CMS experiments have shown is that this new fundamental particle is consistent with the so-called long-sought Higgs boson.
Correct.
But I think the exciting work of understanding its significance now begins.
True.
The findings are pretty preliminary at this stage,
True.
and they're expected to reach maturity by the end of the month.
Correct.
So what are your feelings on this?
Well, I think it is exciting. It is exciting, no doubt. But the only thing is, there is a general conception that maybe finding the Higgs boson was the big main purpose of the LHC. But that is actually not true, because there is so much more that is still left to be done. For example, the standard model does not answer a very big question. That is, how does gravity fit into all of the other fundamental forces, which the standard model so very well explains. And we still do not know much about dark matter, what makes it up, or what makes up dark energy.
I think, yes, you do have a point, but at the same time, I think what is important to understand in this context is that the Higgs boson was the only particle predicted by the standard model that was not so far seen by the experiments.
That's right.
The Higgs mechanism does not predict the mass of the Higgs boson itself, but rather a range of masses.
True.
And I think what is also important, which I can, perhaps would be very interesting, is also to make a clear distinction between the Higgs boson and the Higgs field.
True.
So perhaps you could talk a little about that, the slight difference between the Higgs boson, the Higgs field, and the implications.
Correct. So the Higgs field was something that was proposed by a team of scientists, which included Peter Higgs, in the 1960s. And this was the mechanism by which that there came into existence something called the Higgs boson. And the Higgs boson is the one which actually confers mass, to the various fundamental particles. Because one of the main conundrums has been that, why should these essentially weightless particles, how do they actually go on and acquire mass? And the Higgs boson is this, this intermediary which, via the Higgs mechanism, actually is able to confer mass on all of these particles.
Yeah, I think that's a very interesting point. And basically, you've caught the crux of it, that the theoretical model that accounts between photons and W and Z particles, and for the masses of fundamental particles. Now they have to come up with this whole thing on how the Higgs boson, the kind of different forms that it can take, and how it is linked to theories such as supersymmetry. I think you could just shed some light on that.
So one of the next big holy grail that scientists at CERN are looking for is to look at something called supersymmetry. That is, where they say how there are both, every particle has its twin, and it is actually that by various mechanisms and forces, how these twins break up into simpler forms, or they combine with one another to form all the particles that we know and well understand. However, there is no experimental evidence, that they have not seen any evidence of such kinds of supersymmetric particles. So I think that is going to be the next big line of research, and I think that is going to occupy most of the waking hours of these scientists at CERN over there.
Yeah, I guess now we are actually talking about the dark matter, dark energy, parallel universes, so we get into a different universe altogether.
Leslie, and I was actually thinking that, let's say if we were all in the 16th, 17th century, and we were at the time where Newton actually came up with the laws of gravity, but we do know that there was Einstein who came up some centuries after that. So in a sense, we have maybe discovered, it's like being in Newton's time again, but we know that Einstein is still to come.
Absolutely, I fully agree.
So thanks a lot, Leslie, for talking to us.
Oh, thanks, Jacob. Very entertaining discussion.
So scientists may have found Newton, but will they ever find Einstein? That's all we have from the Mint Newsroom.